For this example, we're going to determine the asymptotes, both the vertical and horizontal asymptotes. We'll find the x and the y intercepts, and we'll make a statement about the domain before we graph. We have a rational function here, which is a polynomial divided by a polynomial. And for rational functions, we do have some rules that we can use in order to make this process a little easier. To find a vertical asymptote for a rational function, just take the bottom of the fraction, set it equal to 0, and solve. That will give you your vertical asymptotes. Horizontal asymptotes, we need to take a look at the degree of the top and the degree of the bottom of our rational function. By comparing them, we have three different rules, depending if the degree of the top is greater than the degree of the bottom, less than the degree of the bottom, or equal to the degree of the bottom. We have three different scenarios that happen there. When you find x-intercepts in a rational function, you can set the top equal to 0 and solve. And for your y-intercepts, we can just plug in 0 for all of those x's, and that will give us the y-intercepts. So for this rational function, if we're going to find the vertical asymptotes first, for vertical asymptotes, we set the bottom equal to 0 and then solve. So x squared minus 5x minus 6 equals 0 would be our equation. For that, we can either do the quadratic formula or factor. Those would be the two faster methods. You could also do longer synthetic division, but factoring or quadratic formula probably would be easiest. We have it equal to 0 already, so I'm ready to try to factor or maybe plug into the quadratic formula. I will try to factor this one, looking for two numbers that add to be the -5 and multiply to be 1 times -6, which is -6. There are two numbers that fit that pattern. They are -6 and 1, and I can use the shortcut. So we would have an x minus 6 times an x plus 1 is equal to 0. And now I have two things multiplied together that equals 0, so we can make two equations out of those, setting each one equal to 0 and then solving. So there will be two vertical asymptotes in this problem, one of them at 6 and then one of them at -1. We are supposed to make a statement about the domain in this problem, and usually after I do the vertical asymptotes, that's when I make the statement about the domain. You could do it later on too, but the vertical asymptotes and domains are very, very directly related. The vertical asymptotes are whatever causes an error for our x values. The domain are all of the x values that work. Or if I say it another way, vertical asymptotes are the x's that don't work, and the domain are all the x's that do work. So your domain you could state in two different ways. You could say for your domain that it is all real numbers except those two values. So you could say all real numbers except 6 and -1. But there is a more efficient way of saying that, and that is simply to take these equal signs and change them into not equals. X cannot equal 6, x cannot equal -1, but they could be anything else. So most of the time people just take the equations they have from the vertical asymptotes and change them into not equals. These two not equal to statements here mean the same thing as all real numbers except for 6 and -1. All right, let's talk about the horizontal asymptotes then. For our horizontal asymptotes, we want to compare the degree of the top and the degree of the bottom. If you take a look at the top, the highest power of x that we have is x to the first power, so it is degree 1 on the top. On the bottom, we have x squared is the highest power of x, so it is degree 2. And in this problem, the degree of the top is less than the degree of the bottom, and based on those rules that I had written down earlier and showed you, if the degree of the top is less than the degree of the bottom, there is a horizontal asymptote, and it is at y is equal to 0, which will be right on top of the x-axis. To go through and find our x-intercepts, we take the top and set that equal to 0. So in this problem, x minus 8 is the top. We set that equal to 0 and solve. We end up with x is equal to 8. We want a point, not a line. X equals 8 is actually a vertical line, but what we want for our x-intercept is a point. I plugged in 0 for y. That's basically how we got the equation that we ended up with, and our x value was at 8. So we have one x-intercept, and it is at 8. For our y-intercept, we plug in 0 for all the x's. So basically we're calculating f of 0. I'm just going to say y equals, and I'm going to plug in 0 for all of those x's. So up at the very top, we would have 0 minus 8. And then on the bottom, plugging zeros in for those x's there, we would have 0 squared minus 5 times 0 minus 6. That gives us a negative 8 over a negative 6. And if we reduce that and simplify, we get 4/3. So our x-intercept we listed here as an ordered pair. I'm going to do the same thing for our y-intercept. I plugged in 0 for our x values, and what I got for y, what y was equal to, was 4/3. Now I have all of the information that we need to go through and do the graph. So I'll take all that information we just came up with, and I'll put that on our graph. So first, we had a vertical asymptote at x is equal to 6. And at x is equal to a negative 1. And how those vertical asymptotes work. Our graph, when it gets close to one of these asymptotes, is going to go up to the top or up to the bottom. So for instance, if we're graphing in between here, the graph is going to go upwards and get really close to the asymptote up here, or come downwards and get close to the asymptote at the bottom. It'll have to do that every time it gets close to one of those vertical asymptotes. Vertical asymptotes can never be crossed. We do have a horizontal asymptote at y is equal to 0, which is right on top of the x-axis. For our horizontal asymptote, our graph is going to get very close to the asymptote, way over on the far left and on the far right sides. It doesn't tell us what happens in the middle, it just tells us what happens way over on the left and way over on the right. And horizontal asymptotes can be crossed. Doesn't happen very often, but they can be. Vertical asymptotes can't be crossed, horizontal ones can. All right, we got a couple of points. We have an x-intercept at 8. And that is actually right on the asymptote, so for sure this is one where the graph is going to hit the horizontal asymptote. We also have a y-intercept at 4/3. So about right there. From there, we're going to need to come up with some more points. So you should grab your calculator and start plugging in some numbers. We're going to be plugging into this original equation. So whatever I pick, I'll plug in for the x's here, and then calculate a y value, and that will give us a point on the graph. Let me start with the graph over here on this left side. I don't know where this is at all. There are no points here at all. But I do know that it's going to get close to the asymptote up here at the top or down here at the bottom, and it's going to get close to the horizontal asymptote out on the edge also. So I'll just need to decide what happens with that. So I'm going to make an XY table, and I'm going to plug in some values. I'm going to plug in some numbers that are close to the asymptote here, like a -2. And then one that's a little further out over, like maybe at -5, and then kind of over on the edge, maybe at like -10, and we'll see what happens with those values. So I'm going to take those values, I'm plugging those into the graphing calculator and having it do a table of values for me. You can use any calculator, it doesn't matter. I'm just going to round these off to 2 decimal places. That's about as accurately as I can graph anyway. So -2, when you plug that in, you get about a -1.3 approximately. It's really -1.25, but we'll round off. For -5, you get -0.3 approximately. And then at -10, we get negative about 0.1. So if we graph those points, we would graph -2, -1.3, so that's about there. -5, -0.3, so that's maybe about there. And then -10, -0.1, that's really close to the asymptote. And we have kind of an idea of how this is supposed to look now. I probably have graphed enough points. I do know as it gets close to the edge of the screen over here on the left, I'm going to have a graph that gets close to the asymptote, so it's going to look something like that. And then when we get close to this asymptote, it's going to either go up or go down. I could plug in like -1.5, but based on this is starting to tip downwards, I'm pretty confident that the graph is going to go downward and look something like that. I want to do the same thing in the middle section. I do have 1 point here, which is pretty close to the asymptote, so I'm going to plug in a couple more points. Let me plug in, let's see, 2, 3, maybe 3. That's here kind of in the middle, so I'll plug in 3 for my x value, and then as a nice integer value close to the other asymptote, that would be over at 5. So let me plug in 3 and 5 and see what we get. If you plug in 3 and then round that off to 1 decimal, you get about 0.4. And if you plug in 5, you get about 0.5. So 3.4 is about here. 5.5 is up just a tiny bit from that. And again, I kind of can tell what's going to happen now. Maybe I need to do a few more points, but I think I got it. It looks to me like the left and the right sides are up a little higher than here in the middle. And I know that it's going to get close to the asymptotes, either at the top or the bottom. This one looks like it's probably going to get close to the top, so something like that. And then on the other side, same thing. This point here is a little higher than this one in the middle. So I think it's going to turn the corner and do something maybe like that. That's probably a decent graph. Over on this right side, I have 1 point, but let me plug in a couple of others. Let me plug in 7, that's right next to the asymptote, and then out on the edge of the screen a little bit more. Mine actually goes out to 12, so let me plug in 12. If you plug in 7, you get -0.1 approximately, and if you go out to 12, we're at about 0.05. If I round that off, it's actually going to be about 0.1 if I round to the nearest tenth. So I have this point already. And then at 7, we're just barely underneath the asymptote, so like right there. And then over at 12, we're barely above, so like right there. I know what happens out here on the right now. It's going to go up above the asymptote, something about like that. Then I think it's going to go through this point, which is a little lower, and then go downward. If I wanted to know for sure, I could plug in like 6.5. That would give me a point probably down here a little bit, but I'm pretty confident that this is going to go down on this side, but it wouldn't hurt to plug in a few more values. So that's, I think, what my graph looks like. If I wanted to double check that, I could throw it into a graphing calculator and go from there, but plugging in some more points would do the job as well.